Alright, so I'm going to go through chapter 5. This is a calculator problem. I'm going to highlight a few things in the beginning that were really important to notice. I notice here that there's endpoints. They gave me the velocity. And I have s of 0 equals 10, which to me is an initial value. And I would need this initial value if at any point they ask me about position. Alright, so first of all, first question, endpoints, and they want to know when the speed is 2. So the setup of this question, I would have already taken my calculator and in y1 put the velocity equation in there. That would have been my first step. And so for part A, what I would do is probably either insert or use a y2 and turn off y1, but you should use y1 to be the speed function, and the speed function is equal to the absolute value of velocity. So I would type in absolute value of the function that's given, and then in y2 I would make it 2, and then I would find the intersections. Other things that you guys don't pay attention to but need to is your window. So my window for this guy would be your x's would go from 2 to 4 because I told you that. And my y values, I don't really care about any y value other than 2, so I'll do 0 to 4 so that 2 is in the middle of my window. And that should be part A. I'm actually going to copy this guy. Oopsie. That is not what I meant to do. Alright, so that was part A. Let's look at part B. Write an expression that gives an integral expression, so nice little hint that gives us position, and a lot of you lost points on this. Position is equal to an initial position plus the integral from the initial value to whatever time I want of the velocity. And that would have been part B. Use this expression to find the position at 5. So even if you got that wrong, you should have recognized if I want to find the position at 5, I need to know an initial position to find it. We focus on this over and over and over because it's so important. If you forget about your initial position that's sitting here or initial value, you will get plenty of problems wrong. In chapter 5, it happened multiple times. You're using the fact that, actually, let me start it out with the original. If I take the integral from a to b of a derivative, it is equal to the antiderivative at b minus the antiderivative at a. And how we use that in calculus class to be an application is they'll ask you for the f of b, they'll give you f of a, and then you'll have to use the integral from a to b of the derivative of that function to find it. So in this case, this was position, and the derivative of position is velocity. And that's how they applied FTC, I believe this is FTC 2, to the problem. Part C, it was a problem that we've done, I don't know how many times I've asked this question. Since chapter 3, you've had this question over and over and over. Remember, you have to know definition. So the definition for a particle changing direction is wherever the velocity equals 0 and changes sign. So once I know that, then I'm going to take my graph. I'm going to change colors here. So I'm going to take my y1, put in the velocity. I'm going to do a window of x's from 0 to 5. And remember, I'm looking for when y is equal to 0. So my y window, I'll do something basic like -2 to 2 so that 0 is right in the middle. You're looking for when it crosses the x-axis because that'll be when it is 0 and where the velocity changes sign. Alright, so that's part B. And then we'll do part C. I'll do that up in this little corner because I think I have enough space. Or I mean part D. It says Is the speed increasing or decreasing? I would love for you guys to go back to chapter 3 and look at how many questions you did on these. Remember, AP Calculus, old information does not go away. You have to remember all of the definitions I give you throughout time, and I do understand that that is intimidating, but that is why we practice so much. So, look in your foldable. Look at the speed tab, the particle motion tab. You should have the definition. Is the speed of a particle increasing or decreasing at time 4? So option 1 is, if you don't want to look at a graph, you would find the velocity at time 4, and you would find the acceleration at time 4. How would I do that? I would use my calculator. Right now we should have y1 be the velocity. So using my calculator on the blank screen, I would do vars, move over to y-vars, y1 of 4, and press enter on the blank screen. And if I wanted to do this one, I would do math 8, which is the end deriv, and I would do essentially the derivative of y1 at x equal to 4, or if you have the old calculator, end deriv of y1 comma x comma 4. And then you're looking to see, are both of them positive, or are both of them negative, or are they different signs? So if they are the same sign, then what's that supposed to say, sign? Then we are increasing speed. And if they're different signs, then we are decreasing speed. Graphically speaking, yes, you can also do this graphically. So just to save a little space, I am going to erase this piece right here and go back. Graphically speaking, you can use the graph. So if I look at the graph of velocity, if the velocity graph goes away from the x-axis, then the speed is increasing. But if the velocity goes towards the x-axis, then the speed is decreasing. So those were the two different ways you could have done question D. Really, I chose this question for part B for chapter 5, but I thought it was an easy question for everyone to do because it was based on particle motion definitions that we've done multiple times. All right, question 2. All right, so let's read. It says the figure shows the graph of f prime, so this is f prime, don't forget, of a twice differentiable function. F twice differentiable right now is telling me that all of my theorems will work. IVT, EVT, MVT. Let's see, closed interval. So I have endpoints. Why is that important? If they ask me for max or min, endpoints will be important. The graph has a horizontal tangent at x equal to 1. So I'll just draw it here. X equal to 3 and x equal to 5. That means there is not a horizontal tangent at x equal to 8. The areas of the regions are given. And f of 8 equals 4, initial value. Alright, initial value means if they ask me for f of b, then I need the initial value, f of 8, plus an integral from 8 to that b value of f prime. Okay, so that's the setup of what I just talked about in the last question. Alright, part A. Find all values of x in the open interval, open, meaning can't use endpoints, for which the function has a local minimum. So I'm going to erase some of the stuff I have here just to give me a little bit of space. I know those are horizontal tangents, and let's get that out of the way just so I have the space to do the problem. So part A, if I'm looking for minimums, and it's asking me to find a minimum on f, then I would do a sign chart for f prime. F prime is the given graph, so I'm doing y values. Alright, so y values at 1 are 0. The y value at 1, 2, 3, 4 is 0, and the y value at 6 is 0. Y values here are positive, negative, positive, and positive. So the question was, where does it have a local minimum? Minimums occur when the derivative is 0. And where it changes sign. And I'm going to put f prime changes from negative to positive. And that would be part A. That last piece was me justifying my answer, which a lot of you forgot to do. Part B, determine the absolute minimum. So part B is kind of related. Now I want an absolute min. So what's the only difference is, look now, they're using your endpoints. So absolute minimum means now I get to use my endpoints. The graph goes up, flattens, down. Oopsie. Let me try and make that fit a little better. So up, flat, down, flat, up. So you should see I have a minimum here at this endpoint, and I have the other minimum here at x equal to 6. So I would have to compare f of 0, and I would have to compare f of 6. And really, if you want to be safe and you don't ever want to have to check which endpoints to do, then just check all three. You can actually do that. I choose not to do that. I choose to check this endpoint because I know that this endpoint is a minimum. How do I know it's a minimum? I'll explain that in my justification. So determine the absolute minimum. F of 0 is equal to f of 8 plus the integral from 8 to 0 of f prime d, I guess, x. F of 6 would be f of, I'm going to use a different color. Let's see. So f of 8 plus the integral from 6 to 8 of f prime. So that's how you do it. I'm going to come over to the left here. F of 0 is a little bit messed up because I would use f of 8, but the integral is backwards. So what I'm going to do, instead of adding the integral, I'm going to subtract the integral from 0 to 8. So integral from 0 all the way to 8 would be equal to, so f of 8 is 4, that's where the 4 is coming from, and then minus all of the areas that I'm going to do here. So this area was 2, this area is 6, this area is negative 3, I believe, and this area is positive 7. Okay? Then the other one I would have to check, and I'm going to erase all this from here again. The next one would be f of 6, which would be equal to f of 8 plus the integral from 8 to 6. So again, same thing. I don't like the way, oh, I actually messed that up here. Sorry guys. That should have been plus the integral from 8 to 6 of f prime dx. Oopsie. So in that case, same thing here. I want to make it minus the integral from 6 to 8, which would be f of 8 is 4, minus the integral from 6 to 8, that's this piece right here, and so that's an area of 7. And then I would have to compare which one is smaller. So that's negative 3, this is 8 minus 3, which is 5, so this one I think is more negative. So let's see, let's actually figure out exactly how much this is. So 8 minus 3 is 5. Wow. 5 plus 3 is 12. 4 minus 12 is negative 8. So f of 0 is absolute min because left endpoint, and f prime is positive after f of 0 is less than f of 6. That would be my justification. Remember, your justification can't be your sign chart. Alright, so that was part B. I'm going to erase the screen so I can do part C. On the open interval, when is the concave down and increasing? So this question, I would need two sign charts. If I want to do concave down, I need the second derivative sign chart. If I want to do increasing, I would need the first derivative sign chart. The graph is of the first derivative, therefore the sign chart for f prime would be based off of y values, and the concavity is based off of slopes, so visually looking at slope. So let's do this guy first because we already did this one. So it's 0 at 1, it's 0 at 4, it's 0 at 6, This is 8, this is 0, this one's negative, this one's positive, and this is still positive. Up here, remember it said it had a horizontal tangent at 1. It said there was a horizontal tangent at 3 and a horizontal tangent at 5. Notice I'm trying to line up my two sine charts. And the slope is negative, positive, negative, and then positive. So the question is, when is the graph both concave down? So concave down would be here. Let's see, I don't like that color. Here and here. Increasing would be here, here, and here. So when are they both? Let's see. They would be both from, looks like 0 to 1. Okay. And then they are both right here in between 3 to 4. So my answers would be 0 to 1, union with 3 to 4, because f double prime is negative and f prime is positive. Alright, and then part D. The function is defined by this guy here. Here's an initial value, which is also, hopefully you notice now, used for equations of tangent lines. So, the slope of the line tangent to the graph at x equal to 3. So they want to find g prime of 3. So to find g prime of 3, I first need, I'll do it over here, g prime of x. So g prime of x, hopefully you realize, most of you that got this problem wrong, you ignored the fact that this is a chain rule. So 3 squared, that's the derivative of the outside. Leave the inside alone. Times, see, blue, times the derivative of the inside. And this should look familiar because we did plenty of problems like this too. Alright, g primed of 3 would be 3 times f of 3 squared times f primed of 3. So 3 f of 3 is given, and that was negative 5 over 2. And then f primed of 3, f primed of 3 would be this point here. So f primed of 3, this is the prime graph, so the y value would give me the prime. That's 4. Order of operations says I have to square this guy first, so I get 3 times 25 over 4 times 4. Cancel the 4's, I get 75. Okay, there's the second one. Again, at the end, I'll show you all the point values so you know where you're losing all your points. And then the third one, this guy, the continuous function is defined on the interval endpoints. If you think of endpoints, I want you to think EVT, max mins. The graph, 2 quarter circles, so this is a quarter circle. That's the quarter circle in one line segment, shown with g of x is defined. Okay, so part A asks you to find g of negative 3, so I'm using the definition, 2 times negative 3, plus the integral from 0 to negative 3 of f of t dt, so I'm just going to be lazy in the next ones and probably not write the t dt. Alright, so this would be negative 6 minus the integral from negative 3 to 0. Alright, so negative 3 to 0, that would be this piece. And that's a quarter circle with a radius of 3. Alright, so quarter circle. So negative 6 minus quarter circle pi r, which is 3, squared. So that would be g of 3. Simplify that out. Find g prime of x, which would be taking the derivative of this guy. So the derivative of 2x is 2. The derivative of this piece would be, you take your x, insert it, f of x times the derivative of x, which is 1. And then find g primed of negative 3, which is 2 plus f of negative 3, which is 2 times f of negative 3 is 0, so not times, plus. plus 0, so 2. Okay, so that was part A. Part B, I'll do up here, says determine the x-coordinate where it has an absolute maximum endpoints. So notice that key, every time I say endpoints, they seem to ask about them. So endpoints, I want an absolute max. I get absolute maximums on G if I take G prime's sign chart. Well, we just found G prime, and that was this guy. And I need where G prime is equal to 0. So I'm actually going to erase this step here. I'm going to leave that down there so we can look at it, because that was kind of the key. So I'm going to erase that 1 because it was just times 1. Alright, so G prime, which is equal to 2 plus f of x equals 0. So look at the way I did the problem. I used the definitions that I've taught you. If you want to find a maximum, you write down the function. Once you write down the function, take its derivative and do its sign chart. And usually that always means take the derivative, set it equal to 0, set it equal to undefined, and so on. So, in this case, let's see, 2 plus f of x is equal to 0, so f of x is equal to negative 2. So you need, when the function is equal to negative 2, that will actually give you the x value where G prime is 0. Well, this line here is the, let's see, I'm going to write the equation of that line. So the y equals, because we don't do guessing, so that would be mx plus b. The y-intercept is 3. The slope would be down 6 over 3, so negative 2x plus 3 would be the equation of this line. And if I wanted to find where the y value is negative 2, negative 2x plus 3, negative 5 equals negative 2x, so x is equal to 5 halves. You probably could have guessed that it was also 5 halves, but I really don't like guessing. If it's a line, find the equation, find the x value, so 5 halves. Alright, so that is the only place in this guy that would have a G prime equal to 0. And because of the fact that that's the only one, you don't even have to do a sign chart. We could simply find G of 5 halves. We could find G of the endpoints, negative 4, and G of 3, and not even do a sign chart, because a sign chart might be confusing for you. So let me erase a lot of this junk here so that I have more room. Alright, so I'm actually going to move this stuff over so we have a little more room to find the values. Alright, so G of 5 halves would be, so you use your definition up here, remember this guy, G of 5 halves would be 2 times 5 halves plus the integral from 0 to 5 halves of f. So 0 to 5 halves would be here, and hopefully you notice that that area and this area, I believe, cancel perfectly. So this just becomes 5 because the integral is 0. The next one, G of negative 4, so this would be 2 times negative 4 plus the integral from 0 to negative 4 of f, and so that would be negative 8 minus the integral from 0 to 4 of f. And that one would be 0 to negative 4, I meant. Oh, I did not switch these, did I? There we go. So minus negative 4 to 0 of f. So negative 8 minus, so that would be a quarter circle, quarter with a radius of 1. So that's that part, plus, so that would be negative because it's underneath the x-axis. And then this guy here, quarter circle above the x-axis, which is why this guy is positive. Pi r squared, r is 3, so that would be a 9. That would be that value. And yes, there's a minus here because of this minus here, because we had to flip the integral. And then the last one, G of 3, 2 times 3 plus the integral from 0 to 3 of f, so I don't have to flip that one, that'd be 6, plus the integral from 0 to 3. 0, ooh, this one is incorrect, I gotta go back and fix that. This is the one, 0 to 3 is actually 0, so that'd be 6. Let's go backwards, sorry about that, guys. 0 to 5 halves would not be. 0 to 5 halves. 5 halves would be about here. Pain in the butt. I know. Alright, so that would be the piece that's here. Alright, so this would be 5 plus the integral, which would be, so I'm going to just call that 1.5. So 1/2 base times height. Base is 1.5, which is 3 halves. So never mind, calling it 3 halves. 1/2 base times the height, which is 3, minus this guy, which looks like the 1/2 base. Base is only 1. Height is negative 5 halves. Let's just double check that. That's 2.5. That's 2.5, so I believe that should be correct. Alright, and then from these three values, you would have to compare and look for the biggest value. That would be part B. So part B was kind of a pain. Part B was a pretty large problem because of all of this. If you wanted to create a sign chart, you would have had to use this value as a sign chart. And yes, you can reason through if they'll be positive, negative, or 0. Let's see, I'm trying to think if there's anything else that I would have done. Let's see, believe that is it. Alright, part C. Part C, point of inflection. So definition of point of inflection happens where your second derivative, and we're doing this still on G, so be careful. G double prime is equal to 0, and G double prime changes sign. Alright, so G of x was 2x plus the integral from 0 to x of f of t. So the G prime we already found, I'm just going to rewrite it, is equal to 2 plus f of x. So this x goes in, multiplied by the derivative of this guy, which is 1, and then G double prime of x would be 0 plus f prime of x. So given that this is f, then G double prime is actually the derivative graph of this guy, which is how some of you got part C right but didn't get part B right. It's because this became 0 and didn't affect the concavity. So I would do a sign chart for f prime from negative 4 to positive 3. F prime, I would need slopes. The slopes of the graph, the slope at negative 3 is undefined. The slope at negative 4, because it's a semicircle, is 0. The slope at 0 is undefined because it's a corner. And then negative after, so positive here and positive here. So point of inflection occurs at x equal to 0 only because G double prime equals 0 and G double prime changes sign. And yes, I would have to write that because it asked me to give a reason. That's my reason. Part D, I think I can squeeze that here. Part D, find the average rate of change of f. Average rate of change of f. So that is average rate of change, A rock of f of x, is equal to f of b minus f of a all over b minus a. Some of you got confused and attempted to do average value of f. It asked me for the average rate of change of f. So this would be equal to f of negative 4, a, b. So let's do b first. So actually it doesn't matter which one you do first, but I will go in the order that you're used to. Alright, so add that. F of 3. This is the graph of f, so f of 3 is negative 3. F of negative 4 is negative 1, all over 7. So I believe we get -2/7. And then there is no point for which f prime of c is equal to the average rate of change. Explain why. Let's see. So, why is this slope? Let's see. Explain why this statement does not contradict the mean value. So this should equal f prime of x, but they're saying it does not, but it's okay that it does not. So mean value theorem means that f of x must be closed, which we have from -4 to 3. So this is the graph of f. There are no discontinuities or undefined points. It has to be continuous. I can draw this whole graph without picking up my pencil between -4 and 3. Good, good. And then that last piece, it has to be differentiable on the open interval. So if the endpoints aren't differentiable, I don't care, but everything inside has to be. So this graph has two non-differentiable points. That's a vertical tangent, and this is a corner. And because of that, this is not happening, which is why it's okay that it's not contradicting the mean value theorem. It's actually the fact that the mean value theorem does not hold. Alright, there we go. There are your 3 free response questions. I'm going to give you the keys now so you see how many points everything was worth. Alright, so here is the first question. So the first piece was worth 2 points. Second piece was worth, oh no, just kidding. This was not the question. Let's see if I can find the right one. So completely out of order, but here is the last question we just did. So the first one was worth 3 points, second piece 3 points, third piece 1 point, last piece 2 points. So obviously press pause if you want to look at the exact answer. Alright, so I found the first question. Sorry that I'm going out of order. Here is question 1, so you can see the point breakdown and the actual exact answers. Some of you lost points also for not rounding to the at least third decimal place. So you can't have just 2 decimal places, 1 decimal place. It has to be exact up to 3. So they even show you right here that they'll take either of these answers. This one only has 1 answer because it must have rounded to 3 and truncated to 3. This must round to 8 but truncate to 7 or the other way around. Truncate meaning just chop off the rest of the decimal places. Alright? And then here is the other question. Sorry that I went out of order. I couldn't remember that I had the key sitting at the bottom of the document. But here is the other question, 1 point. The next piece, remember I said that this was kind of a pain in the butt. That was 3 points. And then part C, 2 points. Part D, 3 points. So you can go back through and look at your parts and how many points each piece was worth. Alright, there's the video.